So today I'm testing the Netzer VLX-170. It's a BiSS encoder. We can see the specifications for the 170. It has 170 millimeter outer diameter and 110 inner. This one is a 20-bit resolution and pretty incredible accuracy. That's good because it's a multiple pole motor. There's a speed limit on this one based on its 35 kilohertz update rate, optional 750 kilohertz. Not familiar with that. I think we have the 35 kilohertz here. 2.5 arc seconds. That's great. It's an absolute encoder, so you can see it has capacitive disk, and there's subdivisions here on the outer rim, and this, along with the inner divisions, allows for absolute on power up. It is a single turn absolute on power up, but it counts the rotation, so that makes it multi-turn absolute. This is not a battery system, but this is like for a direct drive absolute within one rev, but you can continue to count. Yeah, the problem I was running into is I think one of these teeth was getting bumped because I lost the equivalent number of counts, and so we're going to investigate that a little further today. Let's take a peek at the motor first, and you can see it is a direct drive with a big hole in the middle. This is an Orbex motor, direct drive, very nice motor. It has pretty high continuous current in amps RMS, low resistance, low inductance. This motor looked like it was a lower voltage motor. We entered the data into CME here for Copley setup and tuning, inductance, resistance. Actually, I entered it first as a motor, brushless motor with feedback, but today I'm using it as a stepper motor, open loop. And the reason I'm doing that is so that we can look at the absolute encoder. So on the Copley feedback, we got X and X naught for clock and S and S naught for data, +5 and ground. I've wired it in such a way using the Xenus Plus drive, the edge filter. I'm running not at 120 but at 80 volts. The motor has a lower back EMF, so lower voltage may be fine. But we're running into some sort of noise problem, presumably, and so we use the Xenus Edge filter. It's not PWM switching noise that's affecting this thing, it's something else, but this was connected to the feedback of the motor, and I've tapped into it with a RS-485 adapter. I'll show you that one. The RS-485 adapter. Got it from DigiKey, and it's got the USB on one end, the 9-pin, and the little adapter for TX, RX, and ground. I had to power the encoder myself, but that's okay. But you can see there's 4 pins for TX and RX. I'm not seeing the ground here, but it is specified on the connector, so they brought it out to the pin. This is 1, 2, 3, 4, 5 pin connector here. No need for the shield here. I've already got that wired up. So let's take a look at the software from Netzer. I have the adapter here. This is the Copley adapter for CME to talk to the Xenus. This is the RFTI adapter, active management technology. So anyways, running the software, well, we can see the dial here, and can't turn it by hand very well, but I got a current vector going. So there's 10 poles, and you can see the needle here is in the green. So open loop, everything looks great. So those are the poles of the motor. So yeah, we were losing some counts when we were rotating. So I'm going to rotate the motor, and we'll see. Can't look at everything all at once here, but so first we'll take a look at staying in the green, and so we'll go 60 RPM, nice and easy. So it's rotating up. Yeah, you can see it bouncing around there. I mean, that's fine, right? You're in the green, right? But seemed to be a little better when we were going slower. So let's take a look at this here when it's done turning. I'm going to double the speed, and so this is just open loop, so I can look at the feedback. You notice it's, as I go faster, it's bouncing into this, I don't know, I wouldn't call it the bad zone. There still looks like it's good, right? And everything's fine, but it's headed towards the red. Not sure if I can hit this speed here, open loop, with only 6 amps, but we'll take a look and see if, there it goes. Yeah, so as I go faster and faster, of course it consumes more current, sort of a viscous. There's a seal in here, and you can kind of, even when it's disabled, you can feel the stiffness. Let me disable it here. So I got 3 amps going to it now, but let's take a look. So it's a little tough to spin. Yeah, so we were marking 0 position, which correlates with the software, and when I was losing a tooth, we would lose that many counts, and I'd lose phase, and then I'd get a following error and shut down. Let's see if we can go a little faster here. I'm not sure if I've been able to hit this speed yet, but yeah, there it goes. Popped. Yeah, it popped over a couple of times past this little gap here. So I presume that's the danger zone. I wish I could go faster, but I'm hitting a speed limit here with a low current open loop. I'm gonna stall out. Yeah, there it goes. Stall. So you can. So it's not current that's killing us. It's not PWM noise. Although I do suspect that the capacitive encoder needs a shield. It could be the encoder is close to the coil or the magnets, and we're getting some field that's rotating, and it's chewing away at our, I guess this is alignment, but this is quality of the signal, right? So signal to noise ratio, once that gets into the red, you can lose count, right? It's not absolute. It's initially absolute on power up or reset, and then it counts incrementally. So if it loses a tooth, yeah, maybe we're getting a warning on that. Actually, we were getting warnings on this. I had the encoder filter turned on, so I'm ignoring problems. It's a bad idea to ignore problems. So better to not ignore the problems, fix the cabling, grounding, and shielding. I'll chalk this up as a shielding problem with the magnetic field or the coil field cutting into the capacitive encoder. And let me just restore the Orbex settings here so we can take a peek at those. So we got the BiSS, we got the 20 bits, we got the advanced settings, everything's normal. I set the cumulative error to 3. Don't turn that on, but I was just trying to spin the motor and see if I could see the problem. But let's see if we can still drive this motor. Oh, I don't have the encoder hooked up. All right. So save that for save that for another day. My goal here was to show the tools from Netzer used to analyze the feedback, and there's an indication that as we go faster, we get closer to the red zone. This motor is going to have some more shield added to it, and that should fix the problem. Anyways, thanks for watching, and thanks to the guys at Netzer for showing me how to plug in the software and connect it all up.